Okay, expected value. Okay, real quickly, we're going to go ahead. What I need for you to do, first of all, is go ahead and write down everything I have here. If you truly want to understand it, keep in mind that math is not a spectator sport. Typically, you have to write things down, not just look at it. But some of us, maybe we can do it without writing it down. But here's the formula, though. Your expected value is equal to the probability of you winning times times the actual value of whatever you're winning. So, say for example, if you're playing lottery, there's a probability of you winning. You win maybe $1 million. So you're going to multiply whatever probability of you winning times whatever the value of that prize, plus the probability of you losing. So typically, if you have a probability of winning something, you also have a probability of losing something. But at the same time, you're going to multiply that times the initial investment, which is the negative. So if you play lottery and you invested $5, it's going to be a negative $5 in a particular situation. Or if you lose points, it'll be a negative points. But one thing I do want you to keep in mind is that the probability of you winning and the probability of you losing, when you add those two ratios together, or those two fractions, or those series of fractions, they're going to come up to equal to 1. Okay? Now, let's consider a situation. Let's consider a game. Let's consider a game in which two players each flip a coin. If both players' coins land heads up, then player A scores 3 points, and player B loses 3 points. If one or both players' coins land tails up, then player B scores 1 point, and player A loses 1 point. Okay, what we're going to do, we're going to find the expected value of the game for player A. Okay, one of the things I always recommend is that you draw a picture. And so what I've done is that I gave you more of a visual in this particular situation. Okay, take a look at it. The HA stands for heads up for both players. So let's say the first situation, both players actually draw heads. That means that player A is going to score 3 points. Okay, if player A flips a head, player B flips a tails, then player A loses 1 point. Furthermore, if player A actually flips tails and A flips heads, player A still loses 1 point. And finally, if both of them actually flip tails, then player A loses 1 point. Those are all 4 scenarios that you have in this particular situation. Okay, so now, my question, you have to ask yourself the question, what is the probability of player A winning? And that's going to be 1/4. Okay, what is the probability of player A losing? Well, if winning is 1/4, then it's almost obvious that losing is going to be 3/4. And this is how you set the equation up. You're going to take the probability of them winning, which is 1/4, times 3 points. Okay, plus the probability of them losing in that first situation. So you can have 1/4 times -1. But then you remember he actually had the opportunity of losing 3 times. So I set it up 1, 2, and 3 times. Okay, and after that we just do the math. 1/4 times 3 is going to give you 3/4. And of course 1/4 times -1 is going to give you -1/4, -1/4, -1/4. And you add them all together and that's going to give you 0. Okay, so the expected value for player A is going to be 0.